Good morning, dear students. Today, in this video lecture, I am going to discuss the physical properties of aldehydes and ketones. The first is physical state. In aldehyde and ketone, only your formaldehyde is a gas at room temperature. However, acetaldehyde is liquid. But the other aldehydes and ketones, they are liquids or solids at room temperature. It means your formaldehyde is gas, your acetaldehyde is liquid, your acetone is liquid, acetone is a very good solvent also. However, the higher aldehydes and the higher ketones, they may be your liquid or solid. The basic reason is, as we increase the number of carbon, there will be an increase in the van der Waals force, and due to the increase in that van der Waals force, it may have behaviors like liquids or solids. The second physical property is your boiling point. The boiling point of aldehyde and ketones, they are higher than hydrocarbons and ethers of comparable molecular masses. It means if we compare the boiling point of hydrocarbon, ether and aldehyde and ketone, then the boiling point of aldehyde and ketone will be higher than your ether and hydrocarbon. But there is a condition. The condition is their molecular masses must be comparable. It means it should not differ largely. However, the boiling point of aldehyde and ketone, they are less than the corresponding alcohol of similar molecular masses. Here is data. This data is given in your NCERT textbook also. If we compare normal butane, methoxyethane, which is ether, propanol, which is an aldehyde, propanol, which is a ketone, and propan-1-ol, which is a alcohol. Now let us observe the molecular masses. For normal butane, the molecular mass is 58, boiling point is 273, that is your lowest. Methoxyethane, which is ether, the boiling point is 281 Kelvin, which is slightly higher than your hydrocarbon. The molar mass is your 60. Propanol, that is propionaldehyde, it has boiling point 322 Kelvin, molar mass again 58. Propanol, again molar mass 58, but the boiling point is 329 Kelvin. So observe the boiling point of aldehyde and ketone, it is your much higher than the corresponding hydrocarbon and your ether. But if we consider your alcohol, that is your propan-1-ol, in this case again the molar mass is 60, again the molar mass is 60, but the boiling point of this alcohol is much higher than your aldehyde and ketone, because in case of alcohol there is strong intermolecular hydrogen bond, but in case of your aldehyde and ketone there is weak dipole-dipole force. So due to this dipole-dipole force, its boiling point will be higher than the hydrocarbon and ether, but its boiling point will be less than the alcohol, because in case of alcohol, in place of this dipole-dipole force, there is a strong intermolecular hydrogen bond. If you consider alcohol, then see, this is your ROH, this is alcohol, This is another mole of alcohol. So there is a strong intermolecular hydrogen bond in your alcohol. But in case of aldehyde, see, this is one molecule of aldehyde, and similarly we can write this is another molecule of aldehyde. So no such hydrogen bond in between your aldehyde. But there is a weak dipole-dipole force in your aldehyde. So aldehyde have less boiling point than the alcohol. Now next physical property is your solubility. The next physical property is your solubility. So next is, third one is your solubility. The lower member of aldehyde and ketone, the lower members of aldehyde and ketones are soluble in water as they form hydrogen bond with your water. For example, if we have aldehyde, this type, this is aldehyde, and this is your water. Now this aldehyde, it will form hydrogen bond. So see, this is your intermolecular hydrogen bond which is formed between your aldehyde and water. So due to the formation of this hydrogen bond, if we consider ketone, in place of hydrogen there will be your alkyl group. So due to the formation of this hydrogen bond, your lower aldehyde and lower ketones such as acetaldehyde, such as your acetone, they are highly soluble or they are soluble in water. But as the size of the alkyl group increases, as the size of your alkyl group increases, so due to the increasing size of the alkyl group, as you know the alkyl group is of hydrophobic nature, so it will not come in contact with water and hence the solubility will decrease. So for higher aldehyde and ketone, the solubility will less in water, but they are freely soluble in organic solvent. I hope it is very much clear to all of you. Now let us discuss a solved example of NCERT textbook. The question is here, if you consider solve example 12.2. The question is, arrange the following compounds in the increasing order of their boiling point. The compound is CH3, CH2, CH2, CH2. This is your butanol. I hope you know the name of this compound is butanol. The next is your CH3, CH2, CH2, CH2OH. This is your butan-1-nol. The next is your C2H5O, C2H5. This is called your ethoxyethane. And the next is your CH3, CH2, again CH2, CH2 and CH3. This is your simply normal pentane or pentane. Now if you consider, then what should be the increasing order of boiling point? Means which compound have highest boiling point? Naturally we can say this alcohol have highest boiling point. So the order will be your CH3, CH2, CH2, CH2OH. It is highest, and then we have aldehyde, that is CH3, CH2, CH2, CH2. after this aldehyde we have ether, C2H5O, C2H5, and naturally the lowest will be your normal पेंटेन। तो इस तरह से हम लोग इसका जो बॉइलिंग पॉइंट है उसको डिस्कस कर सकते हैं। नाउ इफ यू कंसीडर particularly the boiling point of aldehyde and ketone only. For example, if we have CH3 CH2CHO and if we have CH3CO CH3, both have same molecular mass. The molecular mass of both the compound, perhaps if you count C3, actually it is C3H6O, that is 36 plus 6 plus 14, that is 56. So your molecular mass, whether it is your 36, 12 into 3 plus 6, sorry, not 14, 60. So it will be 58. So both have same molar mass, but the boiling point of propanaldehyde, that is your 322 Kelvin, while for propanone it is 329 Kelvin. Now the question is, why the boiling point of ketone is slightly higher than aldehyde? It is due to the higher polarity of ketone than aldehyde. If you consider the polarity of aldehyde and ketone, your ketone will be more polar than your aldehyde. That's why we can say ketone have higher boiling point slightly than your aldehyde. So I hope this is all about your physical properties of aldehyde and ketone. Thank you.